You don't know the name? Yeah. And she did some of that stuff. I mean, I think she did.
Yes. Oh, yes. So I should have said that. Fine. So sorry, guys. Just I should have mentioned. So I have these lovely little handmade cards, and I will hold them up when you reach the 5, 7, and 9 minute.
Within 1 minute.
Within 1 minute. Yeah. Oh well, then I'll turn off your mic. Okay. Thanks. Good afternoon, everybody. You're very welcome to this session on what are the costs of greening and adapting transport. And this is one of our Spotlight on Research sessions organised in coordination with ECTRI, the European Commission, the Transportation Research Board and WCTRS. So you're all very welcome this afternoon. So over the course of the summit so far, we have been hearing about the importance of greening and adapting transport. And indeed, in our own Transport Outlook this year, we have started to try putting some numbers to the scenarios and estimate investment need to cater for demand under our 2 different policy scenarios. But we recognise that catering for demand is only one aspect of what future transport investment needs will have to cater for. And so I'm particularly interested to hear from our 4 different speakers this afternoon on the other aspects that need to be considered in achieving our ambitions for decarbonising transport. So in order to get the show on the road, I invite Dr. Lou Fulton, who is the Director of Sustainable Transportation Energy Pathways Programme at UC Davis, to please come up and give your presentation on can the US and Europe both achieve ambitious electric vehicle sales targets?
Thank you very much. I think I'll go over here. Just always comfortable at a podium. Yeah. I assume if I press that, I can get the slides. Yes. That's fine. Oh, thank you. Okay, so I'm going to try to be quick. I'm giving this on behalf of my student, Hong Yang, who's a PhD candidate in our program. And she did great work on this, but then wasn't able to come. She is going to get to go to Montreal and present it there, though, so that's pretty good, too. And what we wanted to try to understand a little better was we've got very ambitious targets coming now for electric vehicle market penetration. I mean, it's happening all over the world, but we started by looking at the US case and then thought, well, we really need to look beyond the US, so then we wanted to look at a European case of seeing what it looks like to achieve sales targets and what the investment part of that looks like. And then we've also done a kind of mini version of this for 4 other countries: Mexico, Canada, Korea, and Japan. And so we've presented different parts of this before, but this is the first time that it happens to be me presenting all of it together. And so we're kind of happy to get this far, and we could do more after this. But let's walk through this quickly. We know that electrification is a critical pathway to long-term decarbonization of transport. And we've seen a lot happen just in the last couple of months in terms of the ambition level in the US and the EU. Biden had said he wants a 50% share of electric vehicle sales by 2030. He said that a couple of years ago. Now the EPA has started to act on that, and there are proposed rules to achieve that. Actually gets to 67% by 2032, which is even almost harder to imagine. But and then there's truck targets too, but I'm focusing on light duty. Let me just check my time here. Okay, and EU has low carbon regulations, CO2 reduction regulations, and they've announced they're going to ban the sales of new petrol and diesel cars from 2035. So there's a lot happening between now and 2035, and even a lot between now and 2030. Now, OEMs are catching on, they're doing well, they're selling more and more vehicles, and they've also been announcing plans to invest in production capacity of these vehicles. And what we really wanted to ask was, are they going to keep up? If you have to grow the sales of these very rapidly, are the OEMs in those continents, well, or in case of the US, a country, but we also looked at North America and in Europe, looking good for having the capacity to produce those vehicles. We've also looked at battery investment, but I'm not going to present that today. But we also did look at the cost, since this is about the cost of transitions and the challenges of transitions, and I'll show some of that. And so how do the targets compare with the plans? That's the basic idea. I'm going to skip that one and just get right into that. We looked at, in particular, the US and the EU in more detail than the other ones, and we had different scenarios, partly because when we started this 6 months ago, I think it's kind of gotten more clarity on where these targets are going in the last 6 months. But we decided to look at a couple of scenarios in each case, and here we show on the bottom there that there's lower ambition and higher ambition and mid-level ambition, both on the Europe side and on the US side. And you can see the percentages there in that table, that where they'd be in 2030 in each of those scenarios. Obviously, if they both go to the high ambition, which is the lower right, that's the most electric vehicles that you would sell in each case. And then we were thinking about trade. You know, if one of them is producing more or committed to producing more vehicles than is needed to hit their target, then they could send those vehicles to the other continent, and that's true as we look at more and more countries. If we can find excess vehicles in the system, then if the vehicles move around, it can help make sure that we match. So this is in our paper, you can read all the details about how we came up with our various scenarios. This one actually shows 4. I think it's the second, the orange one, the second from the top, that's the one that the EPA is kind of focused on for the US, and that is the one that we'll mostly focus on here in terms of comparing to the commitments that were made. But clearly it could go a lot of different directions depending on what Biden wants to do, what states want to do, what happens if the Biden administration were to change with another administration that gets rid of the current vision. So, we still don't know for sure which of these lines we're going to be on. And it's important, in addition to thinking, are we going to have enough capacity to provide these vehicles, to keep in mind that OEMs are operating in an environment where it could change, and they want to be a little careful that they don't get way out on a limb in terms of huge investments only to find that somehow the market doesn't materialize. So we wanted to look at those different situations. Same for Europe. And again, we have a few different scenarios. We took them from some different studies that suggested that whether these would be good kinds of trajectories or not. Again, the orange line, the third one up, is the one that looks the most likely. It gets you to 100% by 2035, and it's at about 50% by 2030. So those are the two most important ones. We then took these, now we put them side by side. Oh no, excuse me, this is just the US. We took these and we mapped our work on identifying the investment announcements. And so on the left-hand side, you have cases where manufacturers have said, we're going to build capacity somewhere in the United States, and it could be in any number of states, but we have detailed databases on this. And they've said how big it's going to be, when they're going to build it, and how much money it's going to cost them. And so it could be that it doesn't happen, but it's fairly reliable that they're very serious about this. On the right-hand side, we added other announcements that we're not as confident about. So those are our tentative level of production that we think, has a decent chance of happening on top of the left-hand one. But it's about the maximum we think, given announcements as of, we updated this in January, so it's pretty recent. And of course, there could be more announcements, but at least for 2030, we may be running out of time soon to get announcements that then get built, that then get fully operationalized by 2030. So this is beginning to feel like kind of the situation. And you can see here that 2030, which is there, the firm plus tentative announcements are just about okay for that orange line. But unless we do get more, we're going to really run into trouble pretty quickly as we go up in future years. And if we happen to be on an even faster track, then we're a little off of where we want to be. On the other hand, if the growth were quite slow, there would be excess capacity. Europe looks like this, and in Europe, you've got the firm ones, the tentative ones, and again, here we only show it to 2035, but we're not far off in 2030. So, in general, with the level of ambition we think we're going to see, we actually conclude that it doesn't look too bad if this really happens, if we get this level of production investment. So this is all about the capacity of the vehicles to meet the sales levels that we think we might get. And you know what? I'm wondering if I left out the slide on the actual cost. Maybe it's coming, but I can mention that. Basically, no, it's not on this one. But we're looking at $10 billion of investments for every. It's about $1 billion per percentage point or something like that for EVs in both continents. So we're talking about tens of billions of investments and toward 100 billion on those last two slides. So here we then looked at the situation in the 4 other countries. And there's the 7-minute point. Okay, I'm going to finish up soon. And basically we looked at the base capacity, the announced capacity from what we could find in those countries, and how it compares to sales share targets that we found, and we've documented all this. It shows up as just little quotes here in some cases, but we did the best we could to understand what the targets could be, and then what the targets mean for the numbers of vehicles. And then this is sort of the key slide that takes a minute to explain. But the red and the blue bars are for US in blue and EU in red. And you've got that, if it's a lower target or if it's a higher target, the yellow dots are the numbers of vehicles you need, whereas the blue bar is the firm capacity and the little hash part of the blue is the tentative capacity. So over here, you're in pretty good shape in the US because you only need about 4 million a year, and you're actually going to get 6 to 8 million a year. In the EU, it's not quite as good, but you can do okay with the tentative levels. But in the high, you're a little low, and it did show up on those other slides, but here it kind of shows it more. And if you combine the two, not only are those 2 yellow dots showing you're low in both regions, but the combined shortfall is the difference between the dotted line, that's the combined capacity of the 2 regions, and the red dot on top is the total demand. So you want 20 million vehicles, but the best we think we're going to get is 14. So when you put US and Europe together, you actually have a pretty considerable shortfall here. They're in this high case, and that's a bit of a concern. So you're also not going to have anything left over to trade. Then what I just showed you is on the right. And then if you look at the other 4 countries in a similar way, the level of the bars show the committed capacity, and the level of the dots show what the targets may be. And basically, like Japan is well below the targets we found for Japan. The other ones are sort of close. But again, you're not going to get a lot of excess capacity in the system. I mean, it's looking pretty tight. Okay, so conclusions. We think that it'd be nice if we could use EV trade as spare capacity and across these countries, and it naturally probably should happen if there are not restrictions on the trade of the vehicles, and there are some kinds of restrictions. We're also getting restrictions on the materials that go into the vehicles. But we also found that there's just not going to be a lot of excess capacity for trade. And so we think that the next step is to start exploring other major manufacturers such as India and China, and we do suspect we're going to see, especially for China, there will be the possibility of a lot of excess capacity, and it might tend to push the market that Chinese vehicles or possibly Indian vehicles or other countries' excess production could become very interesting to these other countries. And we found that up to 6.6 million shortfall in capacity, which the shortfall we estimate at 42 billion in investment is needed if you wanted to not rely on imports from other places like India and China. And finally, we should consider further policies and incentives to ensure that the planned capacities will come through, create more clarity and credibility with targets, and policies to support the targets so that the manufacturers are confident in investing, ensure that demand will be spurred in parallel to achieve these ambitious targets, make sure we do get vehicle purchasers out there and sell those vehicles, and then reduce barriers to trade, both for the vehicles and for the components of vehicles. Thank you.
Okay, thank you very much, Lou. And EV uptake is so central to so many decarbonisation strategies. It's great to see work on the feasibility to begin the implementation. So next we're going to hear from Dineth Dhananjaya, I apologise, master's student at the University of Technology in Dresden, Germany, and you're currently working in the area of transport economics. So today we're going to hear from Dineth on improving resource efficiency in transport and the case for cleaner, energy efficient vehicles. Dineth.
Yes, very good afternoon to all of you. So this is about the research that we carried out in the topic of improving the resource efficiency in transportation sector, especially focusing on cleaner and more energy efficient vehicle implementations in a country such as Sri Lanka, which is a developing country and with economic barriers. So, and this is the outline of our presentation, and I would like to start with the main objective of aligning these countries' e-mobility practices with the Paris Agreement. But the main problem is actually taming the energy gasoline. So as you know, the energy consumption within the transport sector is highly increasing, but mitigating with these proper policies within developing countries is a highly crucial matter. And as we can see in this table, so the expected consumption is to reduce from 8.8 liters per 100 kilometers to 4.4. But the problem is whether developing countries could achieve this thing in future. So to that, the main focus of our study was to develop a tool which can be used to identify the baseline for economic scenarios and a methodology to identify, to compare different policy scenarios in future. So to that end, the first objective of this study was to compare the past and current fuel economic scenarios with the fiscal policies. And the second objective was to accelerate the development of fuel economic measures to develop system dynamics model. And finally, support the policymakers in developing and analyzing the e-mobility related practices. Yes. Yes, let's discuss about the procedure of this study. Actually, considering about the mainly widely available tools, one of the few limitations available with the application of the vehicle scenarios in a country like Sri Lanka is that it does not have the capability to use it for the imported used vehicle, which has a higher capacity of the vehicle, and also how to use it based on the CIF value of the vehicles, and also the impact of the other tax waivers, and especially the tax waivers and the concessions. So to that end, we developed 18 categories for vehicles given here based on the fuel type and the engine capacity representing the vehicles. And finally, the developed system dynamic model consists of 2 steps about fuel economy estimation for the base year and the loop behavior of this system dynamics model. And talking about the fuel economy baseline estimation, and based on the availability of the data was used from 2015 to 2019. However, the baseline was considered as 2018. And to consider about the factors to use this system dynamic model, and the time series analysis was conducted. And here, we can see that the average annual consumption of the fuel for the petrol vehicles and the diesel vehicles and the electric vehicles, and with the weighted tax percentage on CF values, it has decreased for the petrol vehicles, and also with the average annual fuel consumption. But this has caused to reduce the total registration in the petrol vehicles as well. However, one of the highlighting things here is that even though few changes has been done on the taxation for the electric vehicles, their number of usage has not increased. So here you can see the modeling approach, the measures and assumptions used, and this modeling approach consists with 3 main steps as considering both the factors through the literature review and the stakeholder consumption, and the scenario design, which is about creating the looping behavior of the system dynamic model and the quantitative assessment. And we check as fuel economy for these measures the impact of the variation of import taxation and the tax concession in here. And here, based on the developed methodology, we consider about 3 main scenarios as target gain scenario, aggressive gain, and modest gain scenario. The target gain scenario is about using taking 50% of the vehicle fleet for the electric vehicles by 2030, and the aggressive gain is about taking 75, and the modest gain it would be for 25. So based on this model that we built, and we could identify that, and for the baseline from the 2018, it was mainly 89.3 of the vehicles were petrol, and 10.5 were diesel, and only 0.2% was for the electric vehicles. But for the target gain scenario, which was the most suitable for the country, and it could be identified that we could go for about 64.2% of the petrol vehicles and increase in the electric vehicles percentage for about 30.6. But when the aggressive gain, the electric mobility, electric vehicle percentage could be further increased to around 45. But for the modest gain, it would be around 15.5%. And finally, you can see from this table the fuel economy distribution for the 3 simulated scenarios. And and in this graph, it provides the reduction of the fuel efficient economy under the 3 scenarios, and we could identify by that for the modest gain and also the aggressive gain. For the target gain and the aggressive gain, it has the capability to identify to reach the Paris Agreement goals. And talking about the policy implications of this, finally, and it could be identified that one of the main government issues was that the providence of the tax concession for the petrol and diesel vehicles, which has a negative impact on, because people are resetting these vehicle concessions as well, and because of that there isn't any platform that can be provided for the electronic vehicles at that moment. And also the tax concession were based on the percentage of the reduction of import tax. Mostly concession holders have brought the higher CFL vehicles, which I mentioned, and the effective fuel efficiency and e-mobility policy measures can be taken according to that. And also through the developed methodology, we could identify by that this fuel economy can be improved by between 13 to 39%. Yes, thank you very much.
All right, thank you very much, Dineth, and great to see such detailed breakdown of the role of fiscal measures in encouraging fuel efficiency. So next up, we'll hear from Dr. Quancheng Huang, who's a professor at the Department of Transportation and Logistics Management at National Yangming Chiao Tung University. And today, Quancheng is going to talk to us about a strategic planning tool for evaluating and prioritizing transport projects and cross-border case studies in South Asia. Thanks.
Yeah, hola, thank you for the introduction. I'm very happy to make the presentation about a tool we developed at the ADB and also a pilot study I conducted at my university. So my name is Quancheng Huang from National Yangming Chiao Tung University. The co-authors are my colleague at NYCU and my former student. And in addition to them, the co-author also include my colleagues at ADB, James Laylor. He is attending another meeting, but he has been very supportive when we developed this initiative. And also there are two consultants, Mr. John Stone and Mr. Lee. They build up the database and implement the planning models. Okay. So in addition, I would like to highlight that I have been in the National Science Committee for East Asia Society for Transport Studies, and I hope that today's presentation will be a small step to facilitate the collaboration with ITF and East. Okay, so first of all, the challenges that we understand that we have growing demand and the infrastructure is critical for transport connectivity. And according to ADB's study, that the financial gap about infrastructure in Asia Pacific is 8 trillion. So we have a very long shopping list, but the resource is limited. In particular, after the COVID, that every dollar counts. So we need some tool to help us to evaluate and prioritize the investment. And this tool has to be systematic and evidence-based. In addition, that because that we have a very strong environmental consideration that during the decision process, we have to take them into account. And finally, it is crucial to enhance the communication and understanding among stakeholders so we can push the project smoothly. Okay. So that's the challenging and in terms of solution, that giving this regard, that's why a SIFT initiative has been kicked off at ADB, Strategic Investment for Transport. In this initiative, that we build up some multimodal, sub-region transport planning model. I will skip the detail about the transport planning models, but ideally the inputs are some socio-economic input data, and then we also input the transport networks, and based on the algorithm about trip generation, trip distribution, modal split, and the route assignments, that the output will be that we can simulate the flows for the entire transport networks. And given this capability of this transport planning model, if we manipulate the input of the transport planning model, for example, we can add a link, we can expand a link, then we can compare the simulated output flows and to evaluate what is the impact of the transport investment. And so that's the tool we are going to use. In addition, in order to facilitate this planning work, we also build up a database that we can help us to maintain the data to make the analysis consistent. In addition, that we build a geographical information system that can have an interactive graphic interaction with users. So that's the big picture of this initiative. Okay, so given these tours that we further conducted some studies. But before I do so, I just want to show you a little bit some slides which highlight why interactive graphic interface is useful. Because if you can visualize the result or your assumptions, it's a lot easier to communicate with your stakeholders and about what's going on. So for the GIS the GIS systems that we have there, as I mentioned, that the model covers 3 subregions at the ADB: Grand Mekong GMS, and CARAC Central Asia, and the success in South Asia, so which pretty much cover almost all of the developing member countries at ADB. And so that's about the multimodal transport networks. And then after the simulation, I'm going to show you that's the traffic volumes in this highlighted in these slides. Also, we can have the ratio between the volume to capacity, so we got some idea about the congestion, and also the road segment speed. Okay, so that's something additional that we can help us to communicate with our stakeholders. So given this capability to do transport planning, and then I conducted a pilot study at my university with my colleagues and my former graduate students. And we particularly choose border crossing exercise in the BBI region, which stands for Bangladesh, Bhutan, Nepal, and the neighboring states, neighboring Indian states. And that happened to be a TA project I reviewed at ADB, so I got some basic data about this project. And the research target is the cross-border point between Bangladesh and the Indian borders. There are 19 potential investments that we can conduct. Most of them are for roads, but there are 3 cross-border points that we also get a rail link. So the decision is how we're going to maximize the benefit by the combination of this cross-border point project. So what's the nature of this decision problem? We got the fixed budget, and we have quite many combinations. Classically, that is kind of a backpack problems that you get a certain capacity in order to maximize the benefit. So what kind of other items you're going to put into your backpack? And then that's what I refer to as the upper level optimization process. And given any combination of a project, investment projects, that we could pass the associated transport network to the lower level, which is the SIFT model I just mentioned that, and then we can get the simulated flows. And then we calculate the benefit mainly based on the time value, time saved, not considering other at this moment. Okay, so that's the nature of the decision problem. And then how to link the project and the model. And for example, for this particular cross-border project, that there are 3 major items. We are going to enhance the custom facilities. We also improve the land port, and also we are going to expand the access road. That's the nature of the project. If we finish this project, we can reduce the link passing time. Also, at the same time, we can increase the capacity of the link, so you are less sensitive to congestions. So I'm going to show you by these 2. I try to avoid any technical details because I think that's the relation between travel time and the link flow. And with the rate curve, that means with this investment that we can reduce the link travel time and also increase the capacity. So that's how we based on that equation. And based on similar idea, actually we can model other things in addition to capacity expansion about links. We actually can consider some institutional arrangements such as motor vehicle agreements, e-customs that will help to reduce the link passing time, or even we haven't incorporated cost, but certain that could be related to cost as well. And also for the environmental considerations that once we have the flows, we can calculate the emissions based on some assumptions. So these tools also help us to understand the emission levels based on the investment. And so we conducted a study, and the key question over here is who benefit and how much. So I particularly choose 3 cross-border points. If we implement the project over there individually, and then I calculate the benefit for the BBIN region, the whole study areas, and also I calculate the benefit only for Bangladesh. That's the central part of the whole modeling network. And then if we implement project number 16, that you got some time savings for the BBIN region, also some time savings for Bangladesh. However, if you implement the project at the point 15, it turns out to be that the benefit for the whole BBI region is positive, but the benefit is actually negative for Bangladesh because of the congested traffic conditions. So it turned out to be a fairness issue that if we implement a project, that's not everyone benefit from the arrangement. Okay, so that will be something that we have to pay attention to in terms of regional balance, fairness issues. And the third one is that if we implement project at point 18, it turns out to be that even for the entire region, the time savings is negative. That means that people suffer from the degraded traffic conditions for the whole region, not only for the Bangladesh, the single country. And why? How could this happen? If we increase the capacity of some point in the system, how come get more congested? And I realized that what I read in my textbook about transport planning does exist in the real world. There's a famous paradox called Bragg's paradox, and this is a typical example that for this such arrangement that we are thinking about building a tunnel between point A and B. Before building the tunnel, that we got to traffic is evenly split on two paths. And then you spend 20 minutes for the first link and then 45 minutes for the next link. But when you spend some money and you have the new links, it turned out to be that all of the traffic will go through start to A and then go through the tunnel and to B. And the two links won't be used. And because the start to A and the B to end are relatively narrow road, and because of the congestion effect, that you actually spend more time. But each individual driver will maximize their benefit. So that's turned out to be, and I think there's a chance that that could happen if we improve the cross-border point, specific cross-border point between Bangladesh and India. So that's the pilot case study. We have to finish it, and the concluding remark about the policy implications and then policy suggestions that I would like to highlight a few points over here, and particular that first of all that because of the time and the resource limitation that we didn't do very careful calibration about the parameters for South Asia. In the past, ADB has finished the model in GMS and CARAC, spent years for data collection, model collaborations. But when this time we build up the success model, which linked the other two, we didn't spend enough time. So we used some default value from the package, software package, so that has not been calibrated. So certainly it would be better that we can improve the model by calibrating the model parameters and collect more data. That's one thing. The second thing is that certainly we want to pay more extra attention to avoid the situation about Black's paradox, because that is hard to imagine. We spend millions or billions of dollars and end up with that we have a poor situation. And the third one is that we haven't finished to incorporate the environmental model. If we have that model, in addition to the simulated flow, we also have all of the numbers about emissions based on the assumption about for each of the mode. And that's certainly an essential part for this initiative. And the next one is that we think that the GIS implementation is helpful. If you can visualize your result, your assumptions, it makes it a lot easier to communicate with the stakeholders, and with more understanding and the communication, hopefully that we can address the issue about regional balance and the fairness and the inclusiveness. So that's pretty much I want to share with all of you, and thank you. Thank you.
Great. Thank you very much, Quenteng. And in a world of competing budgets, it's really important to have those decision support tools available for policymakers. So thank you for that presentation. So finally, we're going to hear from Thenara Silva, an economist specializing in mobility and environmental sustainability. And she's currently working as a transport economist at SNCF Réseau. And we're going to hear from her today on the cost of meteorological hazards on the French national rail network. So thank you very much, Thenara.
Okay, good afternoon. I'm delighted to be here today, talking to you in the name of SNCF, the French rail manager, and a major actor through the low carbon transition and sustainability. So as we own the whole rail in France, we are really interested in the impacts of climate change. I'd like to start today, are you hearing me? It's okay. I'd like to start with this call for action from France's strategy that says that climate change will expose rail infrastructure to significant damage, and this will be a source of considerable economic impacts in the future. I'd like to highlight 2 points here. The first one is that the rail infrastructure is interconnected with other networks in France. So if we have an impact on the rail infrastructure, we'll have an impact over the power grid or maybe telecommunications or even roads that could cause major economic impacts. And the second point that I would like to highlight is that we are already suffering, already being impacted from these weather hazards. As I can mention, like France, every heat wave we have in France, in Paris, every July, and when we can assure a reliable service to the passengers. So if we want to be a major actor into the low carbon transition, we have to be able to get a service that is reliable to passengers, that will be on time, on schedule, and that will be attractive to users. So we are really interested nowadays at SNCF on the impacts of the weather on the French rail network. We already know, we are already suffering. As users and as a company, we are suffering from these impacts, but in what extent? How are they growing? Are they being bigger or over the years? So first of all, I'd like to highlight some key figures on the weather effects on the rail performance. On average, over the French territory, 1 million minutes of total delay are being impacted. We can account 1 million minutes of total delay freight and passenger trains per year, as well as 5,000 total train cancellations per year, only related to weather disruptions. This can impact over 600,000 of passengers per year and are mainly concentrated in the Parisian area, which is the biggest economic center of the country, as well as its capital. So this context calls for the rail network manager to study the system's vulnerability and try to anticipate the cost of these weather hazards, as we have this feeling that they are increasing over time. So in this study, we've concentrated onto weather-related disruptions all over the French territory between 2001 and 2019, so a period of 20 years. And then we divided these disruptions that are weather-related into 8 categories all over the French territory. And here, I like to highlight, actually, the rains. For example, they are responsible for almost 50% of the total disruptions, but they are not as severely impactful for the rail network in terms of total delay and total cancellations. So in terms of delays and cancellations, I like to highlight the strong winds, as well as the thunderstorms and the heat. For the heat specifically, the growing rate of the heat-related disruptions over the last 5 years are higher than 20%, especially in the Parisian area. And these three categories together, they represent 60% of the total delays and more than 70% of the total train cancellations. When I look at the evolution of the weather impacts and the possible trends to the future, I like to highlight that years post 2010 are the most impactful years. And here I like to highlight 2010. It is strongly related to the thunderstorm Xintia in February. 2013, when we had a later winter, severe winter in France, as well as a severe heat wave that impacted Europe, as well as 2018 and 2019, the last years of the series that are strongly impacted by floods and heat waves, especially in south of France. And in terms of increasing the rate, the number of disruptions, they grow at a rate of 5% per year, as well as, but the cancellations and total delays, they grow at a rate of 6 and 7% per year. This means that the rail infrastructure is not only more exposed to weather-related disruptions, but that these disruptions are more and more severe to the rail system. So we've arrived to measure, to quantify the impact of these weather disruptions. We know that they are growing, we know that they are increasing to the season, we know that we are more and more exposed. But we don't know how much this costs to us. And as money talks, and we have a limited amount of resources, of financial resources, we should be able to allocate our resources and to measure how much this costs to us as an infrastructure manager, but as a society. So our work then focused on the cost assessment approach. And we were focusing on the holistic cost assessment approach as we focus on direct costs that I'm going to divide into two categories. The restoration costs, that are costs related to any damage to the infrastructure in the data we get from the insurance data, in terms of physical restoration, as well as workforce necessary to be able to reestablish the system. And then we have the train access charges that the infrastructure manager loses at any time we cancel a train. Because at any time we cancel a train, the infrastructure manager loses this financial amount that the operators pay to be able to get access to the rails. These two components are something that we call direct cost, that financial direct cost to the infrastructure manager. Then for the indirect costs, we focus on the travel time losses that passengers are being affected. And with this, we evaluated from a socioeconomic approach. We're using the number of passengers from each disruption, as well as their value of time, which is obviously divided in function of the region, in function of the type of traveler, and etc. When we pass to the results, and on average, we can see that the restoration costs are between 10 to 17 million euros per year to the infrastructure manager. And the train access charges losses related to the train cancellations over 5 million euros per year. This means that financially, the infrastructure manager is losing right now between 15 to 22 million per year, which is 0.2 of CNCF Réseau turnover. But if we take into account that this amount is growing over the years, it could be something really impactful for the company. If we add to this the socioeconomic costs that are related to delays from passengers and freight trains, they are about 85% of the total costs. As, for example, in the Parisian area, we have a high number of passengers that are being impacted with a delay, and it can be really significant for the society. And the whole amount of the cost of the weather impacts could represent over 100 million per year, not only for the company, but to the whole society. So if you talk about the first implications of this work, mainly our main goal was to understand the cost of weather effects, not only for the company, but for the whole society. By understanding this, we were able to create metrics of vulnerability divided by according to the weather category or the weather impact, and divided to each region of France. With this, we were able to work on a probability model to understand how the costs will grow or not, probably grow, with the temperature and with according to each climate scenario from IPCC. And knowing the cost in the future, we can search for available technical solutions, either renewing rolling stock or maintenance strategies, or maybe transport planning, in order to compare the benefit of this strategy, these adaptation strategies, with the costs of non-adaptation to the society. At the end, we are aiming to prioritize strategies according to the regions in France, as well as the local necessities in terms of infrastructure and passenger freight demand, actually. Thank you very much.
All right, wonderful. Thank you so much, Thanara, for a fascinating insight into a real-life case study. So I'm going to ask the audience to be preparing your questions, and while you are, I'm going to invite all of our speakers up, please, to join me at the front as a panel. So can I invite Lou, Dineth, Kunchen, and Thanara, please, up to the front. Thank you very much. All right, thank you. So before I launch into my own questions, I'd like to give the audience a chance. Does anybody have a question for any or all of our speakers? Okay, well, Matteo was first out of the gate, so I'm going to... Do we have a roving mic? There we go. Okay.
Hello? Oh, perfect. Thank you to all the speakers. I had one specific question for Thanara. I thought it was a fantastic analysis, and I was curious if there are other similar analyses out there that you've looked at and compared to as well, of other transport operators who've done something similar, also maybe not just for rail, maybe for other things, and what some of the conclusions of that are. How does rail compare to road, or how do different regions compare? I think it would be super interesting.
Okay, thank you very much. In terms of socioeconomic costs, we couldn't find another network in France. There are studies in London that helped us to compare our results with the metro system in London, but it's specifically for rail. For roads, I know they are doing adaptation strategies and adaptation studies, but I'm not really sure if the socioeconomic costs is being taken into account.
Okay.
I actually have a follow-up.
Please, go ahead.
For you. Are those socioeconomic costs mainly time related, like lost time for travelers, or does it include other things?
Yeah, mainly travel time loss, reliability time, travel time losses. Every time we have a delay, we value this with the value of time, multiply it by, there was an equation.
Great. I mean, it would be interesting to compare it to the general delay that travelers have by road, right? Because there's probably plenty of delay there.
Yes.
And so you shouldn't feel too guilty if occasionally there's delay on the SNCF.
yeah, but we are trying to take into account. I mean, other factors should be. I mean, our main goal is to compare this with travel demand behavior in the future. So we are aiming to complete the analysis.
Well, I think we will certainly be interested when you do complete the analysis to understand the impact on behaviour.
Yeah.
Okay, are there any other questions from the audience, please? Yes, Henk.
Thank you, Ola. Always Henk from Kim, Netherlands. Thank you for the interesting and relevant research results and the presentations. I have seen some suggestions of policy consequences and possibilities, but sometimes I thought, well, is this what the researchers think that is relevant for policymakers, or did we actually know? Did we talk to the policymaker, or to the responsible manager of SNCF? So I was wondering, is this mainly research meant to be used by others without us knowing that the others were waiting for this research? Or was the research also required, asked for by the policymakers? Was there any interaction? And I know this is difficult because sometimes this is a normal thing and sometimes not, but I'm interested in all of the four speakers' answers.
Okay, great question. Thank you. So a question there on process and scoping, really, and it's to each of the panelists. So perhaps we'll go to somebody we haven't heard from yet. So Huan-Cheng, you have the kind of the dual ADB and university role, so maybe you could get us started.
Okay, so I happen to be involved in ADB and I resumed my teaching career. So certainly I cannot speak for ADB anymore, okay? But for the study I have just finished, it's really kind of a supportive decision making. As I mentioned, the loan contract has been signed. So the money goes from ADB to Bangladesh governments. They are implementing the project. And ideally, it seems that we should have conducted this kind of study a few years ago because it should be part of the feasibility study. But we have been talking about the loan process for MDB to have a project ready take years. So do we really have the luxury about implementing very sophisticated transport planning model and then verify the impact? Well, I know for all of the NDBs, we have to do all kinds of financial analysis, economic analysis to ensure the project is feasible and that we get the green light. However, transport modeling is not a practice yet for any NDB, I think. So, well, I can say that hopefully that the situation I am afraid of won't happen if we do spend money to. The scenario is actually that India has been thinking about moving the goods from India and the main part to the North Indian states via Bangladesh. Otherwise, everything has to go through the very narrow chicken neck, about only 30 kilometers Siliguri. So the issue has been talked a lot. So the modeling tells us that there is a good chance that we need to be careful about which cross-border point to be improved. And then we have to also think about what happened to Bangladesh if there's a lot of through traffic causing the situation very serious to Bangladesh. More traffic means more congestion, but on the other hand, probably more business for Bangladesh trucking industry if there's no motor vehicle agreements that they have to load, unload, and reload. So I think a lot of complexities over there, and so I'm very happy that in my teaching career I got a chance to work for ADB, so provide some suggestions, but I think that it's still how to say that we do get a chance that we provide this kind of decision support to policymakers, because it has been years for the Bangladesh project to think about. So Jamie is not here, so but Jamie is the transport chief, also the co-author. We talked to the project team. Yeah, but it's unlikely that they will stop the project because of this. I should have to say, yeah. Okay, thank you.
Thank you. And Dineth, your kind of identification of the policy relevance of your work.
Yes, talk about this study that we carried out. It's basically based on the Sri Lankan context, but here what we wanted to propose is the method rather than if there's common methods such as FEPIT, which uses to define the fuel economy baselines, but the problem is that in the situations like countries like Sri Lanka, they cannot implement such methods because of the limitations of this model. So we try to propose something that we can use, that can be used for policymakers who are in a similar kind of limitation in their countries, which can use that kind of model in implementing fuel economy baselines, and also comparison of the big scenarios in usage of the electric vehicles. That's the thing.
Thank you very much, Dineth. And Thanara, so you're in the position of already being directly involved in the implementation. So
Yes.
what's the process for identifying the projects?
Yeah, actually at SNCF, this work was presented, was shared with head of the strategy. And now we have a climate change adaptation strategy committee that works every 3 months with the results that we are working on. But again, I only speak for SNCF Réseau, which is the infrastructure manager. Maybe for TGV would be like a great opportunity to, I don't know, with climate change, renew the rolling stock, or maybe create a different schedule. Maybe TGVs that goes really early in the morning because people are waking up earlier because of the heat waves and etc. But we still the work is still under progress at SNCF Réseau, and we're shared with the other SNCFs.
Great, thank you. I think they turned the microphones on and off at the back, so you don't need to worry about that. No, it's okay. And Lou, finally coming to you, I don't know if it was yourself or your student who did the initial identification, but what's that policy interaction?
Yeah, we did it together, and we talked. It's a great question. I mean, maybe we trying to tell policymakers too much about how to interpret our work, you know. But we did this as part of a group effort to think about some of the roadblocks we may run into with the transition to electric vehicles, and that includes discussions with California agencies and the US EPA. So they were very interested in this, and so they were receptive. But I think it's really important to have that policy aspect to research. I mean, unless it's some kind of pure scientific research that doesn't have any specific policy implication. But you need to, as researchers need to ask themselves about the policy relevance to make sure there is some, and figure out what questions are we trying to answer here that may matter in terms of the decisions that people make about where things go. And then the other thing is, it's important, I think, to have that policy piece to try to at least get the attention of policymakers so that they have some reason to look at it. Now, they may not agree with your policy findings, but at least maybe it's kind of advertising your research a little bit.
Great, thank you very much. Do we have any further questions? We have one at the back there. Sorry, clip-on mics were not made for.
Thank you. Good afternoon. Thanks for the presentations. I had a question for Lou, actually. Thanks for the analysis, sharing the analysis. Always fascinating when you start from the ambitions and then you work bottom up to see what's announced and where that gets us. I guess my question was, if you go further upstream, you have other announced vehicle production versus battery manufacturing capacity, and then you can even go one step further, which is announced battery manufacturing capacity versus mining capacity. So I was wondering if you're trying to look at the broader picture, all across the value chain, or if you have seen other studies doing the same.
And as I mentioned, we've done the battery stuff. We're not quite finished with that, but we will do a separate paper on the battery side. And so far, I think it's not looking that good for Europe on the battery side in terms of assembly. I don't know if I think there's going to be more need to import, but we may see some more announcements of investment. It looked a little better on the U.S. side, but I think there's definitely issues there. Going above the battery assembly point to look at the raw materials gets really complicated. So we haven't figured out how to tackle that yet. But obviously, if you have a shortage in the supply chain anywhere along the way, that could torpedo you, even if you have plenty of final assembly capacity. So yeah, we only looked at part of the whole thing.
Can I have a follow-up?
Of course, please.
I think the last comment is quite critical. Based on the experience for the past several years, the bottleneck is actually the chips used for cars. Yeah, so there's a good chance that we have to trace back to see if we really can meet that target for EV.
Yeah, chips are another thing, not related to the EV thing in particular. I think. I mean, it's related to all cars now, getting enough chips. But the materials that go into batteries, I think, are going to be a particular challenge. Right? It's pretty major focus now.
Okay, great. Okay, and I think we have at least one question here. This lady in the second row.
Thank you. I'm Heli Siirilä from Finland, Vaasa University. And this battery talking made me remember where I come from. So 5 years ago, I moved to a small Finnish rural municipality with 4,000 people. And what is special about that municipality is that next year there will be a lithium mine opening its doors and starting its production. And lithium hydrogen is going to be on the market from 2025, so in 2 years. And they are going to drive it for 50 kilometers to Kokkola city. And in the harbor area, there is a plant that will produce the end product. And if we drive 130 kilometers to Vaasa city from Kokkola, they are really struggling and making a big work that a battery plant will open its doors in Vaasa. So in few years, there might be sustainable European, Finnish batteries, lithium batteries produced. So as a kind of researcher, kind of a regional developer, I'm really interested in this whole picture, but this is not much talked about in Finland. So if you or anyone you know is researching on this kind of topics, please remember what is happening in Finland, what is happening in the Ostrobothnia region, because somebody from the outside needs to look at this. So,
thank you.
Welcome to Finland.
Thank you very much. And that's an interesting point. Do you have any insights into future plant production in your research, or are you working?
Oh, well, it's all about future plant production, and I'll double check whether we've got a processing plant or battery assembly plant would be. We wouldn't have the processing plant. We haven't gotten to that point, but presumably there's a battery assembly plant coming to Finland. And I think you're also describing the fact that on the whole supply chain, extraction, processing, and transportation of all these materials, a lot is happening very quickly, and everybody's scrambling to get things in place. I know there's all kinds of stuff going on in Canada right now. So it's a little hard to track, and it's very disruptive, I think. It's going to be very disruptive to communities. It's going to be a lot of new mines. Southern California is starting to get ready to basically mine the Salton Sea, which is a lithium deposit. So we have to pay attention and try to manage those things.
Okay, great. Thank you. Had I seen another hand raised? Yes, in the second from back there.
Thanks very much. I'm Ed Thompson from the Scottish Government. So all of the presentations were fascinating in their different ways and raised a whole range of really interesting issues. I suppose that there's an issue that projections are not the same as predictions, right? So one of the things as a policymaker that's really interesting about various conclusions in the presentations about the kind of the constraints of what's been modeled, and is thinking about what then is the kind of policy prescription that comes with comes off the back of the research and the analysis. And one of the things that occurs to me is that, you know, if there are issues with the supply to meet the demand, you know, we can look at various solutions to deal with the supply, but the other solution is to look at the demand and whether there's the beginnings of a case that looks at a greater policy emphasis on demand management. And just reflecting on the position that we've been in, where administrations that maybe 5 or 6 years ago were looking at things like sales mandates on zero-emission vehicles were seen as taking a very brave, very bold stance. And now that's becoming much more mainstream in what is actually an extremely short period of time politically. There's a very, very small handful of administrations looking at targets for things like demand management around car ownership and car use, for example. But we could be meeting again in kind of 2, 3, 4 years' time with a whole range of administrations and multilateral organizations seeing this as a mainstream aspect of policy for transport decarbonization. And I'd wondered how far, kind of as a research community, just using that as an example, maybe not specifically, but are there other kind of trends like that when you're sort of thinking about your research work generally, where you're kind of trying to anticipate where the policy direction might go so that the kind of analysis kind of reflects or can inform a range of policy options that are maybe just a little bit blue skies at the moment, but the lessons of the kind of climate change policy response is that things can turn very, very quickly, and you know, we need to be in a good position to be able to address that as it happens. Thank you.
Okay, I think that's probably relevant to everybody, but I think perhaps maybe we start with you, Quancheng, and then maybe Lou, we can hear from you, and Thinara and Daneth, if you have anything to add, then that would be great.
Yeah, talking about projection, for the model or the tool I just presented, relatively we use in terms of the demand forecasting. It's kind of mature, the techniques that will make use GDP and the population to forecast travel demands. I don't think there's a huge uncertainty over there. However, for the following steps about how the travelers make the choice about mode or about how we end up with the simulated flow, I think there's a lot of uncertainty because that's related to the behavior of the travelers and shippers. For example, if we do we take into account the cost, how we take into the cost externality, I think that's why those kind of models need a lot of calibration. So I think that would be the uncertainty that we have to take into account. But in terms of demand, that the relationship between GDP, population, the travel, that's relatively stable, I think. Yeah, but the human's behavior, I think that's the major source of uncertainty. That's challenging. That's challenging. Yeah.
And is there a step anywhere where you could reflect an intervention on the policy side around demand rather than following the projections based on GDP and population?
I think based on the framework, I know that's not a perfect framework, but that's the framework they use a lot by transport planners, that the implication, the influence of the policy is more about the decision making. And then that's, I am not that sure that transport policy could be very, you know that for public sector, that's, for passenger side, that I would say that it's easier to do some policy implementation because
the government has a lot of strong influence, or even the government is the apparatus. But for the freight side, the freight transportation, most of them are logistic service provider, private sector, they have their own business agenda. I think it's relatively difficult to introduce policy to influence the shipper's decision or the logistics service provider's decision. So I think for passenger side, we can do a better job. That's just my personal viewpoint about this. Yeah.
Great.
Yeah.
Thank you very much. And then, Dineth, do you want to speak next? We come to Lou. So Lou, questions around the sort of, do you follow the demand for the vehicles, or do you try and implement some demand management?
Yeah, no, there's great thoughts. You're right that it's a big transition, and there is a tendency to kind of start with blue skies, kind of look at getting to EVs, knowing that there are challenges to ramp up. But I think what we are finding is that this is such a fast change that we're trying to do societally. A lot of things related to climate, because we're running out of time, and so we just kind of keep raising the ambition about what we're going to do by 2030, by 2035, in order to try to meet our degree, targets, keep it to 1.5 degrees and stuff like that. But eventually you start to go faster than sort of human capability to change systems. And so, I think one of the things that our research can flag, if it's forward-looking, is where you might run into trouble. And yeah, maybe you might have to slow down sometimes, because, for example, you might just find that you get a huge price spike. We've already had a huge tripling, quadrupling of lithium prices in the last couple of years because of the rate we're going. Luckily, lithium prices are still only about 10% of the cost of lithium-ion batteries, so that's okay for now. But we're going to see more of those things. And if we can flag them ahead of time, we have a better chance of managing it.
Great, thank you very much. And Dineth, your whole presentation was based more around the levers that can be pulled to push, the fiscal levers that can be pulled to push a particular result. But maybe you could expand a little bit on the assumptions that went into your scenarios, please.
Yes, as I presented, there are 3 base scenarios that we presented as target-based, aggressive gain-based, and modest gain-based. Mm-hmm. But these assumptions that we made are actually based on the current situation of the political situations within the country as well. And if we take about the modest gain scenario, which is quite often happening, the policies relating to the taxation of the vehicles often changes. Sometimes it even changes within 1 year. So the modest gain would be that. But aggressive gain would be if everything goes so well and the government has the capability to invest huge investment on the infrastructure, about the capability of electronic mobility and everything. That would be the aggressive scenario. But target gain scenario is like some sort of manageable, where the government just have to deal with the tax concession issue that they are facing right now, and that would be the target gain scenario. So these are the assumptions that we particularly made.
Great, thank you very much. Do we have any other questions? The back row there.
Hi, I'm Jemine Kuba from the International Transport Workers Federation. Just one aspect but great to hear more about is how we can do better to take account of the human needs. And so, for example, the climate impacts are meaning that workers are dealing with increasingly harsh conditions. Transport workers are often on the cutting edge of that. They're the most affected often by new extremities. They're also the ones that keep things moving in emergencies, as we saw through the pandemic. Question for me is, how is that being taken into account in terms of the costs and the resilience building that's needed?
A very fair question. So the reflection of costs beyond direct, these would be more indirect costs in terms of the impact of climate action. So I don't know if anyone in the panel has any thoughts on this? It's possible that it's beyond the scope of the research being done in this session.
Good point, though.
It is, yeah. Yeah. So it is a particularly important point and part of the just transition aspect, obviously, but unfortunately beyond the scope of what was briefed for this session. But on that topic, I think I would be interested to we've heard a couple of questions about the policy relevance and the interaction with policymakers in the context of research. And Thainara, I would love to come to you and maybe ask a little bit more on the results. So what are the possible solutions that SNCF Réseau, for example, could aim for to support network resilience in the future?
Thank you. Okay. No. Yeah.
Yes.
Yeah. Perfect. For SNCF Réseau, right now we are working on different levels. First of all, when we create a new line, there is a line that is being constructed in south of France. That is already taking into account resilience, the resilience of the system, climate change resilience. This is more of a project level. Besides this, we have some kind of programs that are able to track the location, each location of the track, the rail track, and to say to us if this is more vulnerable or not to each category of impact. And then on a more short-term level, I'd say data for us is really important. The question of the data, the monitoring of the disruptions, and we are trying to improve this. That's why we only have from 2001 to 2019, 19 because of COVID, but 2001 because before this we didn't have the data really incomplete. So we are trying to train the people that are entering the data into the system to recognize which kind of failure are related to which kind of category to be able to predict this in a better way.
Okay, super, thank you very much. And just building on the question regarding workers, so obviously that's one aspect of costs that aren't currently being considered, but more broadly, to what extent are SNCF Réseau considering the total costs of weather hazards on their network?
Yeah, good question. So the workforce, we only have insurance data. So is the workforce necessary, the additional workforce necessary in terms of employees every time you have a disruption? So I'm not sure if it answers your question, but I don't only have the cost for this part, but it's a great question. I think we should take this into account. And besides this, in terms of the operating company, rolling stock material, we don't have the data, the necessary data to estimate in terms of rolling stock damage, how it cost us as a group. Actually, I only have the data to estimate in terms of infrastructure, in terms of society, and even in terms of society. Questions like, are the passengers less comfortable because they are suffering from heat waves, and how we can monetize this feeling of being uncomfortable inside the train. We are working on this, and the work is still to be completed, to have something that we hope to call a complete cost of a non-adaptation for SNCF.
Super, thank you very much. And I can speak also from our own perspective of recently trying to complete estimates on the investment needs for infrastructure. Trying to get complete data on infrastructure projects is very difficult, especially when you're asking at the national level, because there's no one office that collates all of the information, as you say, across the lines, across the rolling stock, and that would allow for complete costings. So I thank you very much for your honesty in your answer, but I fully understand the difficulties around data. Okay, so I have been asked to do we have any further questions in the audience? No. Okay, great. So I'm going to wrap up a few minutes early just because we do have the Young Transport Researcher of the Year award happening at 6 p.m. So I want to give everybody time to go over, because I'm sure you all will. At least I hope you will. But before we do that, can I just get a feel for the mix of researchers and practitioners in the room? So if you are predominantly working as a researcher, could I ask you to raise your hand, please? Okay. All right, and if you're predominantly working as a practitioner? Okay, and if you don't really identify with either of those groupings? Policymaker, yes, a fair point, policymaker. Okay, so we have a reasonably good mix across the different groupings in terms of takeaways and being able to implement and either contribute to or build on the research that has been done here today. So would any of our panelists like to make any final remarks before we close the session?
Thank you.
Thank you. That was my next comment. You preempted it. So then all that leaves me to say is that the Young Transport Researcher of the Year Award will be happening at the ITF stand, which is over in the far corner. I hope that you will all join us there. It'll be followed by a reception where there will also be a cultural performance from Saxony, I believe, and then the gala dinner, which will be held in the large glass kind of domey hall that you saw with all the flags in front of it on your way in this morning. So that only leaves me then to thank very much our panelists for a fascinating presentation and discussion. I look forward to seeing the end results or further results of all of this research, so please do stay in touch. So please join me in thanking our panelists for their work. Thank you all very much and enjoy your evening.